This is an example of a hypothesis test and confidence interval for a population mean. In 2017, the average ticket price to a Broadway show in New York City was $109.21. A recent survey of 25 shows found an average price of $114.70 and a standard deviation of $43.30. Our first question: do we have evidence that Broadway ticket prices in New York City have changed since 2017? And our second question: use the sample data to construct a 95% confidence interval for the recent ticket price. How does your confidence interval support your hypothesis test conclusion? So we'll start with question 1, the hypothesis test. Step 1 is to write our hypotheses. So our null hypothesis and our alternative hypotheses would look like this. They're about a population mean, so we're using the symbol for the population mean. And the question asks, have the prices changed? So in other words, are they different from what they used to be? And what they used to be was $109.21. And so our null hypothesis will be that no, they haven't changed, that they're still the same as $109.21. In our second step, we have to show that we can apply the central limit theorem for sample means. And the condition for central limit theorem for sample means is that our sample size has to be greater than or equal to 25, or the population that we're drawing from has to be normal. And in this case, we were told that the sample size was 25, so the condition is satisfied. In the third step, we want to find a test statistic and a p-value. Now, our test statistic is called a t-statistic, and our p-value, both of these are going to be found using StatCrunch. Now, I'm going to show you how to find those at the end of the video, because if I navigate to them now, I'll have to recreate all of this writing. So I'll show you how to find this in StatCrunch, but basically you're going to go to our stat menu like always. The test statistic we're looking for is a t-stat, so we'll be going to go to t-stats. We have one sample, and we have a summary because we don't have the raw data, but we're told that in the problem, we were told that we had a sample mean of $114.70 and a sample standard deviation of $43.30, and we have a sample size of 25. So we're going to put all of this into StatCrunch, and when we do, we're going to find a test statistic of 0.63 and a p-value of 0.53. Now remember, the p-value tells us whether our sample is surprising if the null hypothesis is true. And our p-value is large, so what that means is that it's not unusual to get this sample mean if the center of the distribution really is $109.21. And remember, if you think about p-values, there's a cutoff called our significance level. And a traditional significance level is 0.05. And if our p-value is very low, meaning it's a surprising sample, we would reject our null hypothesis. But in this case, we have 0.53, which is definitely in our don't reject region. And so since we're not rejecting our null hypothesis, our conclusion is going to be there's not enough evidence to conclude. Ticket prices have changed. Now remember, this is a conclusion about all Broadway shows, about the population mean. We know that the sample mean was clearly different than the population mean, but this sample is not unusual. It doesn't give us evidence that if we were to average all Broadway ticket prices, we would get something that had changed from the previous value. Now the second part is going to ask us to do a confidence interval. So I'm going to show you how to do both the test statistic and p-value for the hypothesis test and the confidence interval as I navigate to StatCrunch. Then we'll talk about interpreting our confidence interval. So let's go to StatCrunch. And again, we go to Stat, t-stats, because we're asking for a t distribution for our test statistic. We have one sample, and we have a summary. So our sample mean in this problem was $114.70. Our sample standard deviation was $43.30, and our sample size was 25. So first I'll do the hypothesis test, and then we'll do the confidence interval. So the number in our null hypothesis was $109.21. The symbol in our alternative was a not equal sign. And so our hypotheses are set up. And if we compute, we can see the test statistic and p-value that I recorded on the previous screen. So now what I'm going to do is I'm going to edit this to have it do a confidence interval instead, because we haven't done that yet. So we simply click on the confidence interval link, and we compute. And so we see a lower limit, and I'm just going to round this off to dollars and cents, a lower limit of $96.83, and an upper limit of $132.57. So let me record that on the slide and talk about how that agrees with our hypothesis test conclusion. Okay, so for the confidence interval, we had a lower limit of $96.83, and an upper limit of $132.57. Now, what had we concluded? That there was not enough evidence to conclude that ticket prices have changed. And what did ticket prices used to be in the past? $109.21. I noticed that $109.21 is in the interval. So what that means is that it's still believable that the average ticket price is $109.21. There's no evidence that it's not.